Okay. Let's do one more. Let's do this one, LM. And then the third one I'm going to tell you is going to be the same, but let's do LM. Okay, so L and M. So M is 1, -1, and L is 2 and 9/2. Okay, so
Teachers, pardon the interruption. Can I see the following students in room 308C? Jason Avalos, Lincoln Castaneda, Nathan Castro, Pedro Susano, Osazi Ebahan, Jacob G, Isaac Gomez, Adam Amalidi, James Miller, William Zojo, Christian San Vicente, Andrea Saris, and Avery Leonardo in room 308C, please. Thank you.
over 2. Now we're going to do AB. So here is A and here is B. So B is going to be first. Look at that. So LM is parallel to AC. And this is going to be the same conclusion. KL is going to be parallel to BC. So what, after all this work, have we determined? Well, we've determined that KM is parallel to AC. So the mid-segment of KM is parallel to the other side of the triangle AC. The mid-segment LK is parallel to CB, and the mid-segment ML is parallel to BA. All right, so basically, we've done all this work to prove that. And then we can use that when we go and solve the next triangle. Okay, next we're going to find a relationship between the lengths. So the length of KM and the length of AC. So KM is 1. What is K again? No, K is 6. 2.5, so 5/2. And N is 1, -1. Okay, now we want to get the length of KM, so we need to use the distance formula. This is going to be -5 squared is 25. And this is going to be -1 minus 5/2. So let's go with a common denominator of 2/2. So -2/2 minus 5/2. All of that squared. So we get square root of 25 plus -2 minus 5 is -7/2. Squared. 25 plus 49/4. What's 49 divided by 4? Is it 12.25 maybe?
Yeah.
12.25? Okay, so 12.25 plus 25. 37.25. Square root of 37.25. Now you guys could have done this on your calculator and went to decimals right away if it was easier. I'm just trying to do it in my head. I don't have a calculator in front of me, so I'm using fractions and square roots. So that is my length of km. Now to check the length of AC, I know that my A is 7/8 and C is -3.1. So this is going to be equal to my length of AC, so I'm going to do square root x2 minus x1. So we get -3 minus 7 squared plus 1 minus 8 squared. So this is -10 squared is 100 plus, and then we have -7 squared is 49. So we get the square root of 149. Which is equal to I think I can do this. If I don't have a calculator, 4 times 37.5. So we get 2 times root 37.5. Somebody just check if that's correct, because it should be double. Is that right? Is that right, guys? Root 49 is equal to twice root 149 is equal to twice of root 37.25, yes? Nobody with a calculator? What's the square root of 149?
12.20.
What's the square root of 37.25? 6.1. Looks to me, it looks about double to me. So the conclusion, therefore, is Km is equal to 0.5 of AC. So all of this is going to work out the same. So Lm is going to be equal to twice the length of AB, and KL is going to be twice the length of BC. So all of this is to conclude that the mid segment length is half of the length of the third side. So Km is half of AC. So all of this work to conclude that this is going to be half the length of this. This is going to be half the length of this. And this is half the length of this. Also, going very back to the very first exercise we watched a video on, if this is half the length of this, what is the relationship between LK and KM, or CM? What's the relationship between this and this? They're the same, right? Yeah, because this is the midpoint. So this, and this is the same. This, and this is the same. And they are half of this length. Okay, I think I'm going to stop there. The last thing says compare the areas of the triangles AKL and ABC. So the areas of AKL and ABC. So this triangle with this big triangle. Okay? Now that's from grade 9 to get the area of a triangle. And we know it's 1/2 b squared. Base times height squared. You would work that out. And the conclusion would be that the area triangle AKL is going to be equal to 1/4 of the area of triangle ABC. And triangle area triangle LKM is going to be equal to the area of the triangle KBM, which is equal to the area of the triangle LCM, which is equal to the area of the triangle ALK. That's what you'll conclude if we were to check all the triangles. So let's just go back to the original triangle and talk about this. Okay? So, our triangle AKL, this triangle here, is equal to 1/4 of the big triangle ABC. Does that sort of look right?
Yeah.
This is about 1/4 of this, right? What else? What the other thing that I've said is that the triangle LKM, this triangle in here, this triangle, is going to be equal to KBM. So this triangle is equal to this triangle, which is equal to this triangle, which is equal to this triangle. Do you see that? There's 4 of them. 1, 2, 3, 4. So that's the relationship that we are trying to prove. This triangle here is 1/4 of the big triangle, and it's equal to all of these other little triangles. Hopefully that makes sense. Our final conclusion here is, with no time left, 3 mid segments. Divide area of a triangle into 4 equal area triangles. Okay, that's it for the lesson. I'm going to